Good morning everyone. Welcome to the course Engineering Chemistry. Myself Dr. Harika Patnala, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. This course includes battery chemistry. The basic outline we are going to cover in this battery chemistry are introduction about the batteries and cells, difference between the cells and batteries, components of a cell or a battery, what are the various components present in a battery, anode, cathode and electrolyte, and their details, how to select a anode, cathode and electrolyte. Next, characteristics of a good battery: number of cycles of discharging and charging, the state of a health of a battery, the end life of a battery, the capacity, the energy density of a battery. Everything we are going to learn in characteristics of a good battery. The next topic was types of batteries. There are the three types of batteries: primary battery, secondary battery and reserved battery. And among these, the examples are dry cell, zinc air battery, lithium metal battery and the lithium metal ion battery. So, this is about the overview of the battery chemistry. Let us move to the introduction of the battery chemistry. In 1800, Alessandro Volta invented the first battery, electric battery, in 1800. In 1800, Alessandro Volta invented the first electric battery with the help of zinc and copper, two dissimilar metals. He has chosen the zinc and copper are the two dissimilar metals. With these metals, he has generated the electricity. Let us move to the basic topics: battery. A battery is a device that converts the chemical energy contained in its active materials directly into the electrical energy at constant voltage by means of electrochemical oxidation reduction reaction. A battery is a storage device which is having active materials in the form of chemical, which converts the chemical energy into electrical energy. The reaction is called oxidation reduction reaction or redox reaction, or we call as redox reaction. A cell is a basic unit of device, nothing but basic unit of a battery. A cell is a basic unit of a battery which converts the chemical energy to electrical energy. A cell is having two terminals, one is positive terminal and other is the negative terminal. A cell is having two terminals, one is the positive terminal and other is the negative terminal. What is meant by a battery? Difference between a cell and a battery. A battery consists of one or more of these cells connected in series or in parallel. So, if we connect more number of these cells either in series or in parallel, is called a battery. So, based upon the desired output voltage, we are going to choose the number of cells. In each cell there is an electrochemical reaction. In each cell there is an oxidation reduction reaction has been taken place. Let us move to the next topic is components of cell and the batteries. The first component is anode. Before that, we have to know what is meant by an electrode. Electrode. An electrode is a metal which is having tendency either to lose the electrons or to gain the electrons. An electrode is having either tendency to lose the electrons or to gain the electrons. So, based upon that losing and gaining, electrodes are of two types, anode and cathode. The first one is anode. Anode is also called as negative electrode. Anode is a metal which oxidizes and releases the electrons. So, it gives the electrons. Anode is a metal which gives the electrons to the external circuit and itself is oxidized during the electrochemical reaction. So, anode is a negative electrode. Why it is called negative electrode? It is having electrons. It is readily lose the electrons. When a metal is going to readily lose the electrons, itself is oxidized. That reaction is called as electrochemical reaction or oxidation reaction. The anode is selected based on the following properties in mind. While selecting an anode, we have to keep all these properties in mind. It must be an efficient reducing agent. What is meant by an efficient reducing agent? Readily providing the electrons to the external circuit. An anode which readily provides the electrons to the external circuit. It must have good conductivity. Anode must have a good conductivity and high Coulombic output, ampere hour per gram. So, if you take a 1 gram of an anodic material, it should give the high charge of ampere hours. It should have high lifespan. If it is anode is having high Coulombic output, is nothing but it is having high lifespan. Ease of fabrication and low cost. Example is zinc. Zinc is the predominant anodic metal. Zinc is satisfying all these properties. Zinc is satisfying all these properties. All these are the favorable properties for the zinc. So, zinc is a favorable anode. Let us take the lithium. Lithium is an attractive lightest metal. Lithium is the attractive lightest metal used as anode. Used as anode. Lithium is the lightest metal used as anode. It is having high electrochemical equivalence. High electrochemical equivalence. Lithium is suitable and compatible with the electrolyte. That's why in most of the batteries nowadays we are choosing lithium. And the next component of the battery is cathode. Cathode is also called as a positive electrode. Why it is called positive electrode? It readily accepts the electrons from the external circuit. It reduces itself. So, a cathode is a metal which readily accepts those electrons. Which accepts the electrons from the external circuit and is reduced. So, at the cathode, reduction reaction has been taken place. So, the cathode which accepts the electrons from the external circuit and is reduced during the electrochemical reaction. What are the properties? The cathode is selected based on the properties in mind are it must be efficient oxidizing agent. It should readily accept the electrons from the external circuit. It must be stable and compatible with the electrolyte. It does not undergo any chemical reaction with the electrolyte. The cathode should not undergo any chemical reaction with the electrolyte. It must have a useful working voltage. Example, oxygen. Oxygen is used as a cathode in zinc air battery. It reduces very easy. Oxygen is used in the zinc air battery, used as a cathode. It readily reduces itself by gaining the electrons from the external circuit. Other cathodes are metallic oxides and oxyhalides. In special batteries, we are using sulfur and its halides and its oxides. Sulfur and its oxides. The next component of the battery is electrolyte. See, if we take an anode and if we take a cathode, both are placed in an electrolyte medium. These are connected to a load. This is anode and this is the cathode. Anode, both are connected to the load and this is taken into an electrolyte solution. Electrolyte is a medium. There is the medium through which the transfer of charge or ions has been taken place within the cell from anode to the cathode. It transfers the charges or ions from one electrode to the other electrode. The properties should be, while selecting the electrolyte, the properties in mind are, it should not react with the electrode materials. The electrode should never react with the electrode materials. If it reacts, the unnecessary materials and inactive materials going to be generated. Therefore, the life of the span of the battery gets reduced. So, it should not react with the electrode materials. Safety in handling and low cost. So, the electrolyte handling should be very easy. Little change in properties with change in temperature. If there is a change in temperature, Based upon the climatical conditions, temperature may vary, but the electrolyte changes in property should be very little. If it is highly reacted, therefore inactive materials will be produced, therefore the life of the span has been reduced. So there should be a little change in the properties of an electrolyte with change in temperature. The next one is, the electrolyte is typically a liquid. Generally we will choose an electrolyte as an aqueous solution, a salt solution, or an acid solution, or alkaline solution. Why we are choosing these aqueous solutions? Because aqueous solutions are having good ionic conductors. So these solutions impart the ionic conductivity, but not be an electronically conductive. Electronically conductive. Why so? If an electrolyte is an electronically conductive, there will be a short circuit within the cell. Internally it causes the short circuit. Therefore the battery fully damaged. In such cases, we are choosing the solid electrolytes. In such cases, we are choosing the solid electrolytes, which are ionic conductors at the operating temperature of the cell. If we choose lithium batteries cannot be used in aqueous electrolyte solution if lithium is an anodic metal. If there is in thermal conditions, we cannot use the aqueous electrolytes. In such cases, we will go for the solid electrolytes or non-aqueous electrolytes or molten salts, which are ionic conductors at the operating temperature of the cell. What we have discussed in the today's class? In today's class, we have discussed about the introduction of a battery and a cell and difference between these two, and the components of a battery. Components of a battery. What are the components of a battery? Anode. The best anodic metal is zinc. And the next one is lithium is the lightest and suitable and compatible with the electrolyte. And the cathode is the second component of the battery. Which one is a example? Oxygen or oxides, metallic oxides and oxyhalides. Electrolytes. Based upon the anodic materials and cathodic materials, electrolytes are two types. One is aqueous electrolytes or non-aqueous electrolytes. This is all about the today's topic. In the next class, we are going to discuss about the characteristics of a good battery. Thank you.